name is Alejandro, and welcome back for day 34 of me doing the NeetCode 150 challenge. So today we're doing our very last array set and hashing question, and without further ado, let's get straight into it. Okay, today we get a LeetCode medium, problem 128, longest consecutive sequence, and looks like we've already solved this before, so let's see when that was. Okay, this was also June 2024, so that was like 4 or 5 months ago. Okay, alright, so given an unsorted array of integer nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O of n time. Okay, so example 1. Nums is equal to 104, 201, 3, and 2. Output is 4. The longest consecutive element sequence is 1, 2, 3, 4. Therefore, its length is 4. Okay, so they don't necessarily have to be ordered inside the array. Here, oh, and there can be duplicates, so like 0 and 0. Okay, so there can be duplicates. Which means one thing that we can do is, put all the numbers in the hash set, right? That way it's like we only have the unique numbers. And then we want to know the longest consecutive sequence. So out of all the numbers, so essentially, okay, so one way to solve this would probably be sorted set of nums. Sorted nums is equal to this. Print sorted nums, and we're here return 0. Although, okay, this is not O of n time. Okay, so sorting will probably work right here, like, yeah. And so, yeah, consecutive elements, so it must be like +1 of the previous one every single time, right? So, longest is equal to 0, cur is equal to 0, and we'll do for num and sorted nums. Actually, yeah, we'll do 1. For I in range 1, length of sorted nums. If sorted nums of I is equal to sorted nums of I minus 1 plus 1, then cur plus or equal to 1. Otherwise, longest is equal to max of longest, cur, and cur is equal to 1 actually, right? Because this one is invalid, but it'll be the start of the next chain, right? And here we can do return max of longest, cur. Oh, unknown net. Okay, let's try again. Okay, so something like this works. We can submit. And all right. What if I return longest always? Does that work? Otherwise, I can just do the case where there's no numbers, right? Yeah, then like there's that my cur will equal to 9 at the end and so on. Yeah, so yeah, because otherwise, I'll have cur equals to 1. This I'll iterate no times, and then I do max of 0 and 1 when it's not the case. So here we'll just do if length of actually we'll do it before we even sort. Base case, if length of nums is equal to 0, then return 0, right? There's nothing, right? So that's just a quick if O of 1 check, and now here we can submit, and there we go, right? And okay, this works, beats 99.14%, bada bing, bada boom. But of course, this is not legal because this is O of n log n, whereas the problem, this isn't even a follow-up, right? And there are no follow-ups. This is not even a follow-up. It straight up tells you must do this in O of n time. And I guess, like, okay, even though people found to do this in O of n time, however they did it, our solution just happens to be so fast because the sorted function in Python is just so juiced up, right? And so, yeah. If we did, just the nums itself, maybe it would be a little bit slower. Oh, we might get a wrong solution. Oh yeah, because 0, 1, 2, yeah. So actually, it's very important that we build it into a hash. I just did this to like save, to just get rid of duplicates because they're not needed. Oh my goodness, 99.95%. Get a couple more 9s and you'll get like the Azure SLA policy. There you go, the golden 5 9s. And there we go. Okay, but very, very fast solution, but obviously not a legal one because it's in n log n time. Where this algorithm wants it to be in O of n time, right? Okay, so we can keep this. This is fine. We can definitely equal, we can even do something like list set of nums, right? Unique nums, yeah. Yeah, we can do nums is equal to set of nums, right? So now we have it as a hash set, right? Get rid of all duplicates in event time. Right, so that's fine. If we convert it into a hash set, essentially that way it's like, this is the same thing as doing something like, you know, my hash set is equal to set, and then for num and nums, you know, hs.add num, right? And there you go. So these are just the same thing. Where it's like, obviously in a hash set, every single element will happen once. Now, okay, so we gotta think, how can we do this in event time, right? So let's try to see how they did this in this example. So for something like 1, okay, you want to check like, okay, oh, okay, maybe we, will that not be in squared? Okay, so maybe we do something like, you know, we pick a number like 100, right? And that's like, we check, oh, is there 101? And here there isn't, right? And so as long as that chain exists, then we keep doing that as our longest, right? So like maybe we can do something like def get chain length, and maybe we can remember the answer for every single value. That way it's like, you know, okay, or like something like 1, 2, 3, 4 here. Let's say we do something like 2, and then this maps to 3, and then this maps to 4. Right, and then when we do 1, we do 1 maps to 2, maps to 3, maps to 4. Like there's repeated work here, right? So that's not cool. Maybe what we do is we use a little bit more space, and we remember the fact that like, hey, okay, if I've already done 2, 3, 4, right, and I have a 1 here, and I know the next value is 2, I look up 2 in my lookup table, and I'm like, oh, from 2, the longest chain happened to be of 1, 2, 3, right? So with 1, after 2, I don't have to recompute all this work. I know that my longest chain is 3. So maybe we do something like that, right? So here we'll do underscore init, self, comma, self dot chain, equal this, num to longest chain. Right? And here it's like def get chain, length of chain from mappings. Right, so here get chain length, we'll do self, and then we'll take a num, right? And here we'll say self dot nums is equal to none, and here we'll say, yeah, okay, if length of nums is equal to 0, then it's just return 0, right? So here we'll do a pass for now, and in here, what we will do is, yeah, self.nums, hash set instead of list. That way, of 1 lookup times and no duplicates. There we go. Self.nums is equal to set of nums. There we go. And now we don't have to do this. Also allows for of1 lookup times smiley face. Maybe we can make it this smiley face. Actually, I like this smiley face more. This is my favorite smiley face. Okay, that's just a silly little preference. Okay. And by the way, sorry for my voice. If it is weird or I'm coughing in any way a little bit, I'm still a little bit sick. So there's that. Okay, so now I just gotta think. Okay, so we have the self.nums as a hash set of all the numbers as without duplicates, and you can look up an O one time, right? And so now the point is like, okay, worst case, okay, idea, for each number, if we try to compute its chain, i.e. longest consecutive number elements chain starting from that number, we can keep checking if next number exists in nums by leveraging O of 1 lookup times in hash set. Then, whenever we're computing the length of the chain length from the number, we will cache the result to be used whenever needed again in the future. In the worst case, we will store the longest chain for every unique number in nums, which will require a total of O of n space. As for time complexity, this means that we will only forcibly compute chain for each number once and knock out any numbers alongside the chain with it. This means that each number will have its chain calculated at most once, and from then on there chain be an O of 1 lookupable value for a total running time complexity of O of n. Since, again, only once will each number be considered. Okay, so that's cool. So essentially, this is the idea. I'm just putting it in writing. I know it might not make too much sense, at least for the time complexity, but let's write it out and I'll try to explain my reasoning here, right? Sorry. Okay, so here we'll get chain length, right? So first of all, if num in self.chain, chain lengths, return self.chain length of num. Maybe we call this memo, right? So it's like memoization. Otherwise, here we'll say, first of all, if num plus 1 not in self.nums, base case, num is last number in the chain, right? So if it's the last number of the chain, i.e. num plus 1 is not inside of the hash set, right? Because, like, you know, for example, something like 1, 2, 3, and then 4, then we would try to look up 5, we see that it's not in the nums, right? So out of its consecutive sequence of elements, no matter how long it is, it at most ends at 4, which means that the longest consecutive sequence starting from 4 is just 1, right? Just the number 4 itself. So then we'll say self.memo of num is equal to 1, return 1, right? Here we can even just get rid of this, but like, yeah. Otherwise, we'll say next is equal to self.get chain length of num plus 1 chain length is equal to 1 plus self.get chain length of num plus 1. Self.memo of num is equal to chain length, return chain length. Right? Because like, okay, we're just gonna keep doing this over and over and over. At the end, once we reach the last number of the chain, then, okay, we're always gonna put stuff in our self.memo whenever we can, right? Even this, technically I can just return it because it'll, whenever I check it in the function, like, you know, this if statement, this is an O1 if statement, so I can always return 1. So it's fine if I don't do this, and like, you know, that way I don't blow up my space and so on, but it's fine. We'll have everything inside of the memo. They're at most, and all the unique numbers will be inside of our memo at worst case, which is at worst O of n space. And then this will also be at worst O of n time complexity, right? Because it's like, if something is in my memo, I insta return, right? Otherwise, it's like, I will keep computing the value for each number, but I will only do it once, right? If I've never computed before. So for each number, only once will I do the computation to get inside of self.memo. And what's nice is like, you know, if I have a full chain like 1 here, right? I do 1, and I'm like, okay, the length of the chain starting from 1 is 1 plus the length of the chain starting from 2. The length of the chain starting from 2 is 1 plus the length of the chain starting from 3. The length of the chain starting from 3 is 1 plus the length of the chain starting from 4. And then the length of the chain starting from 4 is just 1 because that there is no 5 inside of nums, right? Which we check in O of 1 time using a hash set. Another way I could do it is just, you know, like, say like, you know, the length of the chain starting from 5 is equal to 0 and so on. But then that's just like, you know, at worst it is still, you know, 2n space, and like in case every number is like, you know, the end of their own set and so on. But why do that if you don't have to, right? We just say like 4 is of length 1 starting from 4. So something like this should work. Right. So this is interesting. Okay, I just have to justify. I'm pretty sure this is O of n though. Now we can just do something like this. Now we'll just do for num in self.nums. Here we can do return max of self dot get chain length of num for unique num in self.nums. So I think something like this might work. Okay, it's accepted. Let's run it. And there we go. Bada bing, bada boom. Okay, so it is slower just because, again, like the Python sort function is like extremely juiced up. Now we just need to completely confirm that my solution is O of n time, right? So here, like, okay, let's think about this. So if I do self.getChainLength, I'm essentially calling this function for every single number in nums, right? So this is, I'm calling this function n times, right? And so you'd argue like, oh, it has to be like, you know, O of 1 time complexity inside that function. It's not necessarily, right? The worst case time complexity inside this function is actually n, right? And you might be like, oh my goodness, you're telling me that this can run at most n times, and you're like this might be an O of n function, and you're running it n times. That's n squared, Alejandro. No can do, right? But that's not true because it's O of n in one call, sure. But the sum of the number of checked elements in all of the calls together will be n. It could be that all n happen to be inside of one call. It could be that it's just 1 per the n calls and so on. Because the way that this is going to work is essentially, yeah, okay, no, this is O of n. This is in fact like O of 2n, which is O of n, right? Because the idea is that, okay, worst case, you know, if something's already been computed, it's O of 1 time, right? And so for each of these, you know, n calls, if I reach this case, then that's O of 1 time, bada bing, bada boom, I'm done. If it's also the end of the chain, it's O of 1 time, bada bing, bada boom, I'm done. Then what I'm going to do is like, okay, starting from the current number, I'm going to compute the entire chain. But every single number in that chain now will have a value inside of self.memo. So in total, I will do an extra O of n work in total. from the n calls to get chain length, I will do a total extra work of O of n of n checks in addition, right? But like, it's not n times n, right? It's n plus n. This is very weird, right? Where it's like, you know, I'm gonna make n calls to get chain length. The number of operations that happens in n calls to get chain length is an extra n is, you know, n times O of 1 plus, again, each one might have, you know, up to n checks, but in total there will be n, right? So it'll be plus n in total after all n calls to get chain length. There will be an extra O of n work on top of it, right? N times O of 1 plus n, like, you know, this just becomes O of n. I'm trying to, I don't know if I'm making sense the way that I'm explaining this, but the point is, okay, maybe we look at an example, right? So we'll think about the number of operations we do. So if we take an example like this, okay. So first of all, I'll say, like, as always in all my videos, I do a quick explanation of how I was able to solve the problem. So here I was going down a tangent of why this is O of n, but I might as well, you know, explain that as I do my solution explanation, right? So that I don't have to do it twice instead of the same video. So the thing that I do essentially is, well, first of all, we realize that this algorithm must run in O of n time, right? And so at the very beginning, I did a very easy, like, sorted solution, where it's just like I sort all the elements. I sort all the unique elements, so I convert nums into a hash set, sort them, and then just do, you know, a linear scan to get the longest consecutive sequence of elements, which is very, very nice and simple. But that turns out to be, you know, O of n log n time, which is not legal because the problem asks, like, hey, this must be done in O of n time, right? And so what I did instead is, like, okay, we'll still take the idea that we'll hash, you know, the set of nums here, right? Because that takes O of n time. And that way we, one, remove all the duplicates, but more importantly, allow for O of 1 lookup times of whether a number happens to be in nums or not, which is very nice because a consecutive sequence of elements is like, you know, starting from x, it'll be x plus 1, x plus 2. So it's like, you know, from a number x, you can check directly, oh, is x plus 1 a number in nums, and so on. Because again, when you use a hash set, you have O of 1 lookup time. So we're just leveraging that, which is very, very nice, right? So essentially, this is all I do in my function. First of all, if the length of nums is equal to 0, I just return 0. That's just a trivial base case. Otherwise, I convert, you know, my nums into a hash set so that I have O of 1 lookup times and no duplicates. And here, if you want to take a read, I don't know if I wrote this in, you know, in the most clear way possible, but this is essentially an idea. The idea that I use to implement the solution. In case you want to pause the video, take a look at what I wrote and so on, and blah blah blah. So I'll just give you an extra 5 seconds to do that if you want. So like 5, 4, 3, 2, 1. 0. Okay. Otherwise, essentially, okay, just very small line of code, but I'm going to be calling this get chain length function for every single unique number inside of self.nums, right? Because again, self.nums is the hash set converted version of nums, which will have it's just a hash set of all the numbers in nums, which will just you know, only occur once because again, it's a hash set. When I try to add a duplicate number to the hash set, it just it doesn't do anything, right? And so here it's just like, okay, iterate over all the numbers in nums, which is O of n work, right? As long as this is O of 1, which it is not, but I will explain why my solution is still O at n. So here, out of for every single number, essentially, I'm going to calculate the length of the chain starting from that number, right? So what this would look like for a value like this is like, okay, we're going to first compute, you know, here self.get chain length, I have a self.memo. So here we'll say self.memo is equal to, you know, dictionary. You know what, let's move this on over here. Let's put triple quotes. Sorry. Okay, so self.memo, this is essentially like, you know, number to longest chain length, right? So here we'll start off with 100, self.nums is equal to this, right? So here we'll start off with 100. From 100, what is the length of longest chain? Okay, so we want 100, right? Then we're gonna look, okay, by the way, this is a hash set, so, you know, it'll only contain the unique numbers and everything. So from 100, it's like, okay, Well, the longest chain from 100, let's check if 100 plus 1 is in there, right? So 101. Is 101 inside of self.nums? It is not, right? So therefore, the chain ends at number 100, right? So inside of my self.memo, I'm going to say, hey, the length of the longest chain, or the only chain, starting from 100 will be of length 1, right? Because it includes the number 100 itself and nothing else. So it's of length 1, right? Then let's do the next number. So the next number is 4, right? So from 4, let's check, okay, 4 plus 1 is 5 inside of my numbers, right? So 5 is not inside of here. So the length of the longest chain starting from 4 is equal to 1, right? Just the number 4 itself. Sorry. Now same thing for 200. For 200 is 200 plus 1 in there, right? 201 is not in here, so for 200 the value is going to be 200 maps to 1, right? Now this is where things get interesting, right? Now for number 1, I'm going to say, okay, what is the length of the longest chain? Let's first check 1 plus 1, 2. Is that inside of my self.nums? It is indeed inside of my self.nums. And remember, self.nums is a hash set, so I can look up an O of 1 time if a number exists in there, right? So here I take 1 plus 1. That takes O of 1 time to compute, right? Adding 1 to a number, which is 2. And I check, is 2 inside of my hash set? It is indeed. It is right here. So, okay, my current length of the chain is equal to of length 2. Now the next number, what would it be? It will be 2 plus 1, which is equal to 3, is 3 inside of my hash set. It is indeed, it is right here, so I can add 3 in here. Now, okay, the number after 3, if it would exist, would be 4. It does 4 exist inside of my hash set, all right? Here it does, so I'm gonna do, put in 4 here, and so on. And then from 4, is there the number 5, and so on? There is not, and so on. So the length of the longest chain from 1 is equal to 4, right? So here it's equal to 4. And then I would do the same thing. It's like, what you'll notice is like for 3, we've in fact already computed the longest chain of the length starting from 3, right? So it would be really uncool to have to, recompute this and then, be like, oh, 3 maps to 2. And then for 2, we've also already, computed the whole work of like, what the length is from 2 and so on up to 4. So, so this is like, length 3. And then the maximum one out of these guys is 1. So we return 1, 4 essentially, because that is the maximum length that we've gotten so far. But what you'll notice is like, here there was some repeated work. Even here, right? Computing the length of the longest chain from 4 was something that we had done before already, right? So what I did is like, hey, if I write this algorithm, it is O of n squared time, right? In fact, if I get rid of my self.memo, right, this would still work. But if I submit, this will be extremely slow. I wonder if we time limit, oh yeah, and it's 10 to the 5, so I'll actually time limit exceeded because of this. So let it go through. But yeah, you'll see I time limit exceeded when I don't use memoization. So now let's get rid of all this nice puppy stuff. Forgive me. And here, okay, let's submit one more time. And now you'll see just a snap of a finger, we just get a working solution, 95%, very, very cool. But okay, I'll explain again why this is the case. So if I do something like this, what you'll realize is like, hey, my solution right now runs in n squared time. For each number, I look at what is the length of the longest chain from that number, right? And for a specific number, the length of the longest chain might be, the length of the entire chain from that number, which might be the entire length of nums, right? So like you might have, n for the, like if you're unlucky, right? Maybe you have self.nums is equal to something like, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to n. And it's like, oh, you do this one first, and then you calculate that it has a length n chain, right? So your solution, so this is a length n. Then you look at 2, and you look, this one has a length of n minus 1, right? And then this is like, 3, this is like n minus 2, right? So it's like you do n plus n minus 1 plus n minus 2 plus dot 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 plus 1, which is, the same thing as 1 plus 2 plus dot 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 plus n, which is equal to O of n squared work, right? So, well, this is equal to n times n plus 1 over 2, which is O of n squared work, right? So that's not good, right? N squared is not allowed, definitely not. Our sorting solution was definitely better than O of n squared, so we cannot do that. But here's the thing, right? When I do, when I compute the entire length of the chain starting from 1, then when I get to 2, like, as part of the chain from 1, I already calculated the length of the entire chain from 2. So what if in this example, when I calculated the chain from length 1, I calculated for every single numbers through that chain. That way, when I get to 2, it's like, oh, I already know the solution, O of 1. Oh, for 3, I already know the solution, O of 1, right? So it was O of n work for number 1, and then for every other number then on, it was O of 1 work, right? So essentially, I do n loops, and first iteration, O of n work, all other n minus 1 iterations, O of 1 work, right? So this becomes one loop with O of n work plus n minus 1 iterations of the loop times O of 1 work. And as you can see, this just becomes O of n work, right? So in that case, it actually works out very nicely. And so we can just use this idea all the time. What I do inside of my code is essentially like, hey, if we come back to this example, after we did, 104 and 200, what I do is very clever. I know, like, okay, I do my base case, which is like, okay, if a number is inside of self.memo, that means I've already computed before, so I return an O of 1 time. That's essentially what I was saying. Otherwise, if the next number starting, from a specific number, which has been the case for 104 and 200, is not inside of self.nums, then I know it is the end of the chain. So I put it inside of self.memo with a value of 1, because the length of the longest chain starting from that number is just the number itself, so it's 1, right? Otherwise, it is a number that is not the end of a chain and is legal. So what I do is every single number throughout the chain, I will update their values independently as I go through the chain, right? So for something like this, let's ignore the fact that we've done this work here. What I'll do is, like, starting from 1, I'm like, okay, from 1, okay, what is the length of the longest chain starting from 1? Well, I don't know yet, right? So I'll keep that in my cache, right? So longest from 1. Well, this is going to be equal to, okay, is 2 inside of my hashet, right? 2 is indeed inside of my hashet, right? So let's think about this. Whatever the result is for 2, the result for 1 is just going to be 1 plus the length of the longest chain starting from 2, right? Because, again, 1 comes right before 2. So I can compute the length of the longest chain starting from 2, and then for 1, I'll just take whatever result that is and add 1 to it, right? And so I can just compute the length of the longest chain for 2, right? So here's like, 1 is a question mark so far, 2 is a question mark, right? So from 2, we're going to say, okay, 2, what is the length of the longest chain? Is 3 inside the hashet. It is indeed here. So for 2, the length of the longest chain is, so this is going to be answer for 2 plus 1, right? This is going to be answer for 3 plus 1. Right? And then here from 3, it's like, okay, is 4 inside of the hashet? 4 is indeed inside of the hashet, right? So that means it will go next. So for 3, the answer will be, answer for 4 plus 1, right? And then when we get to 4, well, 4 has already been computed. It's already inside our self.memo. We know the result value is 1, right? Even if it wasn't in our self.memo, 4 was later, we essentially see like, oh, 5 is not in the hashet, so its length is just 1, right? So we know that the answer for 4 is just 1. So 1 plus 1, this becomes 2. 2, that means the answer for 3 was 2. So 2 plus 1 is equal to 3. Right? And for the answer for 2, we know that it's 3. So 3 plus 1 is equal to 4. So just in the sweep, starting from number 1, we were able to get the answer for every single number alongside down its chain. Right? So the chain is 1, 2, 3, 4, and just in the sweep starting from 1, we were able to get the result for every number inside of that chain, right? So for the number 1, for the number 2 here, for the number 3, and for the number 4. Because again, the value for each number inside of here will essentially be 1 plus the 1 in front of it, right? So for 2, it'll be 1 plus whatever the length of the longest chain is from 3, which will be 1 plus whatever the length of the longest chain is from 4. And for 1, it'll be 1 plus whatever the length of the longest chain starts from 2. This just works nice and recursively that way. And again, hopefully that makes sense, where it's like, given that idea, it doesn't matter how many chains there are and how long each chain is, I will essentially only compute the value of the longest chain for each number once, and then put that inside of my memoized library, where I can look up in O of 1 time the result for a specific number, which means I will be making n calls to this self.getChainLength function, and inside of it, I will do an extra O of n work inside the combination of all n calls to that function, right? What I do is essentially, it's like, okay, if I've already computed the result for this number, right? Given, I'm querying this function for a specific num, right? If I've already seen the answer before, I'm just going to return that answer that I've computed before in the past, right? So that's O of one time. If this is the last number of the chain, i.e. num plus 1 is not inside of self.nums, which we can look up in O of one time, then is the end of the chain, so the length of the longest chain starting from that number is just the number itself, you know, something like 4 down below here. So the answer here is just 1, right? And I might as well cache that inside my self.memo and just return 1 is my answer, right? Otherwise, and this is the cool part, the chain length starting from my number will just be the chain length starting from the next number, i.e. num plus 1 plus 1, right? So for something like 1 here, the length of the longest chain starting from 1 will be the next number, i.e. 1 plus 1, which is equal to 2, and it'll be 1 plus the result of the longest chain from number 2 here, right? So this is why I do 1 plus the length of the longest chain from the next number after my current number, right? Whether it's 1, it doesn't matter what it is, whatever its value is going to be 1 plus that, right? And then every single time, here I'm going to say, okay, self.memo of my current number is equal to whatever that chain length that I computed is, right? But when I recursively compute this, well, what am I going to do? I'm going to essentially update self.memo inside of there, right? So the point is that I make n calls to this function, right? And this function only does O of 1 work, but, you know, throughout the entire thing, but it also makes calls to itself recursively. But the number of recursive calls to itself in total will be the amount of numbers inside of self.nums in total. So out of all n calls to get chain length, it will do a maximum of n other calls to self.get chain length, right? So at most, you will have 2 times n calls to this function that otherwise only does O of 1 work. So O of 1 times 2 times n is O of n, and therefore we have an O of n solution. So I really hope that explanation made sense, and that, you know, at least in terms of the algorithm, why it works and so on and everything. I just really want to clarify the fact of why this solution is actually O of n time. The point is that for each number, you will store the length of the longest chain from that number so that you can look it up in O of 1 time if you ever need it later on. And as you go through the chain, starting from a specific number, every number that you see in the chain as well, you will recursively compute the length of that number's chain, right? So like for something like 1, it's like, we know it's just 1 plus the length of the longest chain from 2, which is just 1 plus the length starting from 3, which is just 1 plus the length of the longest chain starting from 4. And we know 4 was 1, so therefore it's like, okay, 3 is 1 plus 1, which is 2, and so that means that 2 is just 2 plus 1, which is 3, and then, okay, for 1, it's just whatever the length of the longest chain is from here, which is 3 plus 1, which is equal to 4. So as you go through a chain, doesn't matter where you start in the chain, you will recursively update the values for the rest of the chain, so that even if, like, you know, even if I put, like, you know, 1 over here, and it's like happens to be at the end, right? And it's like, okay, I don't actually have 1 because what I did is, like, you know, from 2, when I got to this 2, I got the length of the longest chain from 3, which I had already computed and whatever and so on, like this. Then when I get to length 1, to the number 1, I don't compute, you know, the length of the longest chain from here, like, directly, which would result in, you know, O of n squared work in total. What I do is, like, okay, the next number is 2. Well, 2 is already inside my cache results. And I know the length of the longest chain from 2 is equal to 3. So if the chain of from 2, you know, to whatever number, here happens to be 4. If I know the length of the longest chain starting from 2 is equal to 3, and by the way, I say longest, but like there is only one chain from every number and so on. It's just me using language here. But the length of the longest chain from 2 otherwise, we've already computed to be 3. So what is the length of the chain starting from 1? Well, we know that the next number after 1 is 2. So it'll be just whatever this result is plus 1, right? So 1 plus the result from 2 and onwards. 2 is 3, so it'll be 1 plus 3, which is equal to 4. Right? So it doesn't matter where in the chain we do stuff and so on. The amount of recursive calls that we'll do to get chain length in total out of all n calls that we actually do to it in the first place over here inside of this max function will be n. Therefore, n plus n equals 2n is O of n work in total. Again, it's just very, very confusing in the sense that a singular call to get chain length might result in O of n work, right? And so you'd be like scared and say like, oh, this is an O of n worst case algorithm, and I'm iterating over this n times, this must be n squared. No, out of all n calls in total to get chain length, it'll do an additional total of n calls in total, resulting in n plus n equals 2n calls in the worst case, and 2n, being O of n in running time complexity. So again, just trying my very, very best to make that clear, and I apologize if that's confusing in any way, shape, or form. But otherwise, that essentially wraps up my explanation to this problem. I know a little bit of a confusing one, so if it was confusing, just let me know down in the comments, and I'll be happy to clarify anything that might have been a little bit confusing. But otherwise, I hope that you guys understand my solution here. And a very, very cool one to get in O of n time. I love these types of problems because at least in my advanced algorithms class, man, I fell for like this trap like so many times where it's like I'd have some idea that actually turned out to be the actual valid optimal algorithm, but then I'd be like, oh no, this thing, like let's say for this example, I would be like, oh no, worst case we have to look through a whole chain, right? And so this is O of n, and we do n iterations, so this is n squared, this algorithm doesn't work, and so on. But you have to look at what actually happens under the hood, because once you realize that, like for example in this example, it will yes, the worst case complexity from a singular call to get chain length might be O of n, but that's because in all n calls to get chain length, there will be a total of n computations in addition to that are done, which could be done all in one call, but then all the other calls will be O of 1 and so on, and there you go. So you always have to, like be aware of these types of situations where it's like the complexity might actually be better than you think. And in this case, it is not n squared, it is O of n. And so yeah, but that's gotten me, I'm not gonna lie, that has gotten me a little, I could have solved some of my assignments a little faster if I realized these types of tricks in my advanced algorithms class when I did it in uni. But otherwise, as always, let's make sure that we come in here and check off the fact that we did this problem, which is actually a super nice milestone, because now that means we're finally done with arrays and hashing for the rest of the NeetCode 150. So we'll never more be doing another arrays and hashing problem for the rest of the NeetCode 150 challenge. We've completely finished off section 1, which feels very awesome, very nice, very good. All problems solved for arrays and hashing, and which means that in the next video, we'll be moving on to 2 pointers, starting with 2 sum 2 input array is sorted. But otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.